Hello, hello, everyone. How is it going? How's it going? Welcome to yet another stream. Hello. My bad, but at least we know the voice works. Okay, my bad. Sorry for that. Okay, how is everybody doing? How's everybody doing? How is your Tuesday? If you were in office or if you're working, how tiresome it was. And how was it? Thank you everyone for joining. Welcome to yet another stream. And today, what are we doing? Today we are solving some Leetcode problems. Well, if you have seen my live streams, I kind of hop between things here and there. The main point is it's not a course that I have to keep on making series. It is not something like I don't want to feel bound by it. I don't want to feel bound by certain things, and I just want to enjoy the process of this software and content creation together. So that is why I mostly live stream, and I haven't created any video yet. And second thing is that second thing is I haven't yet come up with a proper structure of what all things I want to do. So I'm kind of going into series sort of thing here and there, where one of them is the Grow Chronicles, one of them is Algorithm Art, today what we're doing. So similarly, I'm thinking of having this niche set where I have a couple of series together, and the entire process is just exploring different technologies and learning and having fun writing some software. Okay, that's what the entire goal is. Yeah, that's what the entire goal is. I hope the music is not too loud for you guys. I'm just gonna check that this thing is not too loud. Yeah, that's what the entire goal is. I hope the music is not too loud for you guys. बोलो। अच्छा मैं म्यूट पे हूँ ये बोल रहा हूँ। अच्छा ओके 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 ओके। So here's the thing. Am I still losing data? No, I'm not dropping frames, so it should be good. Okay, so okay, just let me know in the chat if the zoom is correct or I should zoom even more. I can do that. It's kind of like huge for my face, but okay. So I think, anyways, not coming to the point of, you know, this thing in here. So let's look at one of these options, right? So let's look at one of these options and how we can try to approach this. So you have A and B as an option. Then the second one would always be C. And the third one would be, so basically from here you have two branches, which is A and B. Then you have a single branch, which is C. Then from here you have two different branches. Well, not D and E, D and E, and then in here you would have a single branch. I mean, it's kind of like wrong that we have done it in this way. So let's just represent it like this. Okay, so you have the root node. From here you can have A and B. Then you have two nodes in here. From here you can only have C and C. Then from here you can have D and E. Then from here you can have F only. So it has to be A, C. One of the important things here is that we always want to do it lexicographical order. That's one thing to always remember. So the length is not high, 50, which also means that the maximum amount of things that you can have in here is so if you have 50 minus 2, which is equal to 48. So X number would be the number of characters that you can have, and X minus 1 would be the commas that you have, which is equal to 48. Sorry, which means that 2x equal to 49, which means it's not possible. So let's take it for 24. So we can branch out 24 times, which means at every single place, not at every single place, at a certain node, you just branch out 24 times. That's all. Right? You just branch out 24 times a single place. So I think the depth of recursion won't be that high. The depth of recursion won't be that high. One of the things you can always think about here is that you have a single letter, and then you have 49. Yeah, so I think it should still be fair enough. So how we're gonna do here is that I feel we're gonna first parse, and if it's an opening bracket, I'm gonna parse till the point where there's a closing bracket. Once I have the closing bracket, I have a bunch of characters in here, right? I have a bunch of characters in here, and since it's only English characters, what we can do is we can have an array of 26 for that particular thing, and if a particular character is present, we're going to just mark it 1, and the rest would be 0. So in this particular case, what happens is that we can easily say, hey, I will iterate always from the first, and when I branch out, I'm going to branch out with that certain character, which means that it's always going to be sorted. That's one thing. The second thing here is I feel we have to every time create a new array, because if not, if I try to create a global one, which I can just clear out before iteration, the problem here would be, so let's say there is something like a comma b, and then a comma b again. Okay, so in here 1 1, and then you have, you know what, since it's 26 characters, instead of a vector we can say cannot do that, because there is no guarantee that it cannot be a. Can be a. Question here is, can you do something like instead of valid input, is that a valid input, right? Okay, so I think here is a good point in here. Since I do not need the count, I only need the presence of a character. That is why I was using vectors. But instead of vectors, since it's 26, I can now replace it with a 32-bit integer. But I can use it as a bitmap. And I can just say that if 26 is present, I mean, if A is present, sorry, if A is present, we can do it in a reverse order, like how a low endianness would look like. So we can say this is representing, like, you know, so this is the 2 to the power 0, 2 to the power 1, right? So we can always say that, okay, 2 to the power 0 is representing the character A. And we have 26, so there should be enough things. So hopefully all characters, okay, it's only lowercase letters, so that is quite important, as I mentioned. Okay, so, and in here it also says that the length can be 1. If the length is 1, there is no way that you can have what if empty? Is this a valid input? That is also not a valid input. Okay, now this is a valid input. Cool. Okay, so this is what we're gonna do. Oh, I already started doing it today morning, as I mentioned. So first we have this thing where what is it? Yeah, I'm not dropping frames or anything. The sound seems correct. Okay, I'm really sorry for that. Okay, so what happens here is that you have index length. So if you have reached the end of it, I have an accumulator to which I just add a buffer, the current running buffer, which should have the word. This is where I need to either say this or that. So s.char at index, if this is not equal to an opening bracket, I'm gonna have to say sb append s.character at index. We can extract it out and say this is character. And then I can say expand exact, and then I have to say remove delete caret sb length -1. So that is what it's supposed to do. I can simply return here, you know. So if not, what are we gonna do? Parse till we find the closing pair. So in cursor, so let's just say start is basically index plus 1. Sorry, index plus 1. And then we can say key while index is less than s dot length. Now this should never violate, but it's a guard for us. And while this is not this, I'm just gonna say index plus plus. Okay. Okay. So we have to go from start till index minus 1. We can always say like this, right? And accumulate what all characters we are looking at, right? So int cursor is for int I equals start. Start, we already said index plus 1, so we should be good there. This is this plus, but we're always going to skip over by 2 because of the fact that there's a comma in between, right? Okay. Int bitmap. Okay. C equals s dot character I. Int j is c minus a. We can say that. And what do? You can simply say 1 left shift by j, so it will be 0, and then bitmap or this thing and reassign it sorry, back to bitmap. Parse the character options. Cool. Okay. So again, I equals 0, I less than 32, I plus plus. We can simply say bitmap. We can always write shift by 1. And I forgot the Java thing in here. Versus this, which is signed. This is signed. Sorry, and this is unsigned, right? So I would take an unsigned shift operator in here, and I would say and 1 int bit is 0 is present, let's say. So if it is present, you know what, we can simply do this. If this is equal to 1, we are just gonna say the I plus a. Character C is this. Well, I have to cast it like that. SB append ch, then you call expand s, but it's gonna be index this time because we already moved over to the place sorry, plus 1 because we already had this particular thing. So then this, my laptop is getting, my PC is getting a little slow, like consuming a lot of stuff. No, it's 1.3% CPU only, so I don't know what's happening there. Okay, sb dot delete character addressing, and that should be it, I feel. Okay, so let's call this function. We pass this. So we can pass a new string builder, and this here should be list string accumulator is new, right? I think there is something better. Okay, that is pretty good. So a check. Is this the first time I'm solving this problem? Yes, it's the first time I'm solving this problem. Yay. First good one. Right? First good one. Cool. We nailed the first one. Time for the next. Sorry. Just want to look at one thing quick in here. Okay. So, we solved a problem. How many problems did we solve? 22. This guy solved 61 problems. Wow. Wow, good. Good. Factor combinations. Okay, let's try to solve the second one. Numbers can be regarded as a product of their factors. For example, 8 is 2 into 2 into 2 is equal to 2 into 4 also. Okay, given an integer, return a possible combination of factors. You may return the answer in any possible way. Note that the factors should be in the range 2 to n minus 1. Of course, you cannot actually you cannot consider the self itself. Okay. That's interesting. What's the maximum n value that you can pass me? 10 to the power 7. Interesting. Okay. Because what I'm thinking right now is again just a tree. So let's say you have the number 8, right? So you can divide anything by 1. So I'm not going to start that. So every time I'm in a method, I'm going to start a loop from 2 to n minus 1. Sure. 2 to n minus 1, right? So is it divisible by 2? Yes, it is divisible by 2. So I'm going to divide it by 2 and pass on. So 8 is divisible by 2. So 2 to 7 basically is divisible by 2. So you pass down as 4. Divisible by 3? No. By 4? Yes. So you pass on to 5? No. 6? No. 7? No. So you don't have any other branch in here. 4 is divisible by 2. Yes. So again 2 to 3 basically. Then you have 3? No. Okay. So for 2 to 1, this is kind of a mess. Okay, so how do you do that? Because I was thinking we're gonna stop at 1, but since we already go till n minus 1, so basically 1 into 8 is not a possible solution in here. We always have to like exclude 1 and 8 in here. I'm just trying to think ahead that what is one of the things that I should be able to do to say that, because I cannot simply say 2, because there can be 9 also, which should come down to 3 in here. Sorry, should come down to 3 in here, right? Because if I just consider the number and n minus 1, this becomes 2, so this loop never goes through. I suppose a very simple solution here can be trying to divide the number by itself. Trying to divide the number by itself, but that poses another problem where 8 would come up to be 1 into 8, right? So are we correct? Yeah, we are correct. So it doesn't have to be, like, you cannot consider the 1 combination in here. You cannot consider the 1 combination in here, right? So how do we do that? I suppose if it's a prime number, when would you come to a prime number? If you're at 13, this is a prime number. If you're at a prime number, you know that, okay, you cannot divide anything anymore, so you can simply just, do that. But the point here is that you also got to figure out if it's prime or not. And to figure out if it's prime or not, you can go from 2 to something like 8 by 2 minus 1. Is it not that? Kind of forgot. I'm not talking about sieve of Eratos, whatever. Sieve of Sundaram is another one. Square root of n. Wait, what? Really? This can tell you that it's prime? Why is I5? I don't know. You're always incrementing by 6 for some reason. Huh, that's what I'm exactly saying. But I feel like we can also go up to square root of n. Can we not? Sorry. This is the sieve of Eratosthenes, yeah. Ah. Correct. So this is what I'm talking about. One, two, three, four, five, 6, 7, 8, 9. Yeah, so we can do that. We can do that. So I think let's get started, right? I think let's get started. 254. Hmm. Okay. Okay. So is prime. So if it's a prime number, we need to stop right there. New array list of buffer. Just return in here. This is what we're gonna do. For other numbers, for int factor is 2, factor is less than n plus plus. Okay. So if you can divide, I'm gonna add it to the buffer. Awesome. Look at that autocomplete. Wow. And you can see remove last. I think with Java 21 or something. Yeah. So new release, and this is gonna be an accumulator. Awesome. Did not work. Hmm. 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 So why did it switch over to 4-3 and not to 3-4? It's quite interesting. We have run into a little bit of duplicates. So let's think it through. So this is 12. And when you go down this path from 2 to 11, 2, yes, it's one thing. So first of all, you can divide it. It means it's a legit, sorry, it's a legit 2 into 6. We can put it into the accumulator and we can pass down 6. So 6, 2, 3. So 2 into 3. But in here, 3 into 2, which is something that I do not want, I feel. So we can do is 2 to 6 minus 1. So 2 to 5 will go on this. Because if I go down this path, I know exactly I have to go on that path also. All right. Oh, sorry. Mhm. I'm sorry. I'll just take a quick break. Skype constantly pinging me. I have to call him. I'll take a quick break and come back, and then we're gonna try to solve this. With that time, enjoy some music. Yeah. Hello, we are back. We are back. So let's actually get started with that. Let's actually resume what we are doing. And one thing I want to quickly do is reduce this. Cool. Cool. Where is my phone? Let me get my phone. Here, cheese. Cool. We are back, and I think we can resume. Okay. So, what were we doing? We were doing this. Okay. So basically, what we're trying to do here is the factor combinations. So we kind of have to figure out what are the factors. So there are a couple of different ways of doing that. There are a couple of different ways of doing that. One of the things I think we can do is okay. So let's do with 12. Right. So we have 12, and we can get the factors from 2 to 6. If we're getting the factors from 2 to 6, one of the things we always go ahead and do is what? I think my screen share is okay. So from 2 to 6, if I go, which is n by 2, so probably I have to go to n by 2 minus 1. So I have to go from 2 to 5. So I can divide it by 2, I can divide it by 3, I can divide it by 4. Once I go down this path, I want to say so I can divide it by 2, which means that 2 and 6 is one of the things you can add to the buffer, to the accumulator. Sorry. So I feel one of the things we can simply do here is that we can say that we already added to the buffer, because just think about this. That's one thing we cannot do, I suppose. So from 2 to 5, what are the things they can divide it by? 2, 3, 4. Right. Maybe I can go to square root of 12. Because I go from 2 to square root of 12 is square root of 9 is 3 point something, so it's still 3. So we would go from 2 to 3. So that, I feel, is one of the things we have to go with, which is math dot square root, but we gotta cast it to an int here. That's one of the ways to go forward. But we are still at a problem, but that's fine, I think. So now what happens is that, so when it's very first time and it's n, so it's 3, 4, 6. Still we have to go till the square root. So 2, 6 is 1, but here we are having 2, 3, so that's kind of wrong. Why? Because 2, 3 is 6. So why did I not add the other one around? You know what? I'm gonna put this on backlog and I'm gonna try to solve something else because my head is starting to pain right now. Sorry. Okay, cool. So what's the next thing that we can do? Boundary of a binary tree. Apparently I solved it, but I never solved it correctly. Attempted only. So was it like okay, it's the wrong answer. Year back. Let's see if I can solve it now. The boundary of a binary tree is a concatenation of the left boundary, the leaves ordered from left to right, and the reverse order of the right boundary. The left boundary is a set of nodes defined by the following. The root's left node is a left boundary. If the root does not have a left child and the root node's left child is the left boundary. What? Okay. If the root doesn't have a child, then the boundary is left empty. If a node is in the left boundary and has a left child, then the left child is the left boundary. Has no left child, then the right child is in the left boundary. The leftmost leaf is not in the left boundary. Motherfucker, what you're talking about, man? Except in the right side. Again, the leaf is not part of the right boundary. Okay, let's see. For this problem, the root is not a leaf. Okay, so you have this where you have 1, 2, 3. So this is the boundary. 1, 2, 1, 3, 4, 2, 1, 3, 4, 2. Okay. The left boundary is empty because a root does not have a left child, and then the right boundary follows the path starting from this thing, blah blah blah. That okay? So if you have this, you go from 1 to 4. So my entire point is if I consider for every level the leftmost, if I consider for every level, well, let's just draw this 1, right, 3, 4. Okay, sorry. 1, 2, 3, 4. If I consider this level, and this level, this is 1, so we don't consider at the root. Then on this thing, we have null as the leftmost and 2 as the rightmost. On this level, we have 3 as the leftmost, and then 4 as the rightmost. And then if you go down, it is 1, then null, so you don't consider that. After null, you consider 3. After you consider 3, and then you can consider going like this. So once you reach the level which is last, you can consider going here and then going to. So if it was 1 and then null and 2, and then you have 3 and 4, I can go like this. So this is null, I don't do it, so I skip over and I go here. Then since this is the last, I consider going from here till the 1, like I don't go back here. The question here is, how do I exactly know to put a null here and not in here? Because if there was a 3 here, this would have become 3 and 2. And then in here, in this particular level, so let's say there was a 4 in here. So let's quickly see what exactly is the response that they're looking for. So null, instead of null, let's put a 5. If you have a 5, and then you can have a 4, and then you have a null, then you have a null. Can you not type? Can you not? Apparently I cannot. Okay. We have 2, so let's make this 40. So this is not something that we're gonna do. So after 2, this is this, and this null needs to go away. Okay. And in here, is the stream lagging right now? Is the stream lagging right now? No, I don't think so. Okay. So, man, I cannot. My brain is really messed up. So you have 1, then you have 2 and 3. Okay, cool. So the left child of 2 is 4, and then a null. Then if I say 5, it becomes a left child. Yeah. And then 6, exactly what I want to do. So so if I run this, what is the expectation? Wait, yeah, okay. The expectation is 1, 2, 4, 5, 6, 3. 1, 3. 1, 2, 4, 5, 6, 3. 5, 6. Okay. So you have to go through the edges. You have to always travel through the edges. The bigger question, the bigger question here is, if at a certain point you come and say that, hey, like yeah, this could have also been null. In that particular case, it's just 1, 2, 4, 6, 3. So you always have to travel to the edges somehow. Okay. So if this was null, and you remove that, and do that, it has to be 1, 3, 6. Right? 1, 6, 3. Sorry, 1, 6. No. Acha, since there is no left child at all, you were just skipping and saying there is no left node. But then if there is no left child, but there's a right child, what happens if I put 4 in here? Where exactly does it come? It still comes there because, okay, I get it. Because it's the terminal node. But what if I say 10, 12? Now what do you do? You still go like this: 1, 4, 10, 1, 4, 10. So basically, whatever is the leftmost node. But then again, it's 1, 4, not 1, 3. It's always 1, 4. Let's take this example. I feel this example is quite interesting because I feel this example is the one where I can figure out how to do this kind of shit. Okay, so you have 1, you have 3, you have 4 in here, 6 in here, 10, and then 12. Let's look at the bias. Maybe that is gonna help. So if this is 0, so always if you go right, it's a +1. So this is +1. Then you go left. So this is again 0. This again 0. Then this here is +2. This is +1. This is +3. Okay. So if you take on a scale, if you map this thing on your x-axis, you only have 0, 1, 2, 3. So you have 0, 1, 2, 3. So if you map it here, 0 is going to be 1. Then another 0 is there, 4. So let's say it's bind together. Then you have 1, which first comes in as 3. Then it comes in as 10. Then you have a +2, which comes in at 6. Then you have a +3, which comes in at 12. So now the question is, I cannot simply scan like this because 6 on the, you have to go on the other side when you come to 6, right? That's the thing. You have to go on the other side when you come to 6. So what if I say, since it's the same level, it's in the same bias from the midsection, it's gonna go like this, 1, 4. That. Then if it's a positive thing, you append things on the other way, 10 and then 3, and we already fucked up, right? It's already messed up. Interesting. How else can we solve this? Is there any hints that we can get? There are no hints that. Okay, cool. Let's look at this. If you do a DFS in here, it's gonna be 1. It's gonna be 3 because it's the right node. Left is not there. Then you're gonna have 4. Then you're gonna have so 1, 3, 4. They're gonna go back up and come down here, 6, 10, 12. I feel we have to do some kind of post-order traversal in here, which should help. But then 1 is not something that's gonna help, honestly. Right? It's not gonna help because, yeah. So you can have 1, like you basically go down this path. You take this, go down. So you process 4. You go up here, you go down here, you come down here, then you process 10. Process 4, then 10, then 12, then 6, then 3, then 1. Maybe that's the trick. What if we change the input a little bit? Let's change the input a little bit. What happens now? Let's do this first. Okay, so you have 1, so you go down, so you have 10. Then you have 12, then you have 4, then you have 6, then you have 2, then you have 3, then you have 1. The orders are not quite right. I think I do need a hint on this because it seems like I cannot solve it. Apparently I did. I'm guessing what I did. Let's see what I did before. If node is left, right, run, return. Okay. So just say strs, and you separately take out the leaf nodes. Okay. Okay. What exactly is this? So I'm also switching over the direction somehow. If the direction is this, if the left node is not none, you go left, else you go right. Okay. Else, if the direction is the other way, if node.right is first, you try to node.right, you go there. If not, then you try and travel to node.left. Okay. How's it gonna happen? I mean, it's already a wrong answer, but let's read it again. The left boundary is a set of nodes defined by the following. My cat is again running behind a honeybee. Not a honeybee today, but it's a different insect. And yesterday, he was running behind a honeybee and he slapped it, and the honeybee stung. And after that, he started crying and he started shouting. So we got him some medicine, everything. So we did everything. And for the entire evening, then he was very, very quiet. And we thought, oh, he learned a lesson. Or did he? Or did he? So he's there again right now, chasing another insect. What would you know? Yeah. Okay. The right boundary is similar to the left boundary, except it's on the right side of the... Okay. Back to the problem. The left boundary is a set of nodes defined by the following. The root's left child is in the left boundary. If the root does not have a left child, then the left boundary is empty. If a node is in the left boundary and has a left child, then the left child is in the left boundary. If a node is in the left boundary, has no left child, but then the right child is in the left boundary. Sorry. The leftmost leaf is not in the left boundary. Okay. So, from the root, if the node is a left child, it's in the left boundary. If it doesn't have the left boundary, is empty. Straight up empty. But from the root itself, if I can go down the left child, and it does have a left node, after that, whatever, like, so it is always about the child and not about the root. It's always about the left child of the root. But coming back to the same problem where you have this. How do you explain this? It is 1 4 5 3. 1 4 5. Okay. I think I got it. I'm gonna do it in a very nice manner. I think I got it. First, we're gonna always work with the left boundary. So the left boundary should be simply where I go down. I start from node.left. If it is empty, if it is null, I return null. If not, what I do here is that I say, hey, go till the terminal node. Go till the terminal node. Because here, just let's add this. But then this is this. And 6. If this is like this, well, that is again a terminal thing. So which is 7, right? So in here, I'm guessing it should be 1, 2, 6 as the left boundary. 1, 2, 6 as the left boundary. What if the right child it's something like this, right? So something like this. What happens then? Is the left boundary 167? It is 167, 1, 2, 6, 7. 1, 2, 6, 7. Okay. If a node is in the left boundary, has no left child, but has a right child, then the right child is in the left boundary. Okay, I'm going to do that. So let's first figure out left boundary. 545. Just give me a second. Okay, so I'm gonna do it in that way. I think it's a naive way, but at least I'll get things moving for now. As long as it is, I'll get things moving, and later on we can always optimize, right? So private list void traverse left boundary. Okay, and in here I'm just gonna say node. So if node is null, I'm gonna simply return, and or well, we can always say node.left equals null and node.right equals null. You simply return out. We're just gonna make sure. I don't want to leave it a chance, honestly. So yeah, not gonna leave it a chance, honestly. So I'll do that. This is this, and of course you need teacher that integer buffer. Let's call it an accumulator for now, right? So if we just go with this particular, I hope you guys can see this. So if I just go with this very particular statement that the root node's left child is in the boundary. Okay, so I'm already assuming that you're gonna do a check here and then pass. Or well, technically we don't have to do that because we do this, right? So if it is null, you simply go out, right? So what you do is accumulator.add node value. That's the very first thing you do for the left boundary. In fact, we'll do it for any other boundary also. Okay, cool. So now you say if a node is in the left boundary and has a left child, then the left child is in the left boundary. If node.left is not null, why try to be smart when you can simply just read the problem and code it out, right? Traverse. So look at that. Yes, that is exactly what I want to do. And else I'm gonna do this. I'm gonna do this. That's all. That is all. Okay, that's pretty much it. In here, we can simply say traverse this. So root of left, and then here you can have left bound boundary. Okay, that's all. Right. Boundary. Left boundary. Right. Then the second thing that we want to do here is traverse the leaf nodes. Well, we can always do it like this, not like this. Like this. So traverse leaf nodes. So you have that, and technically speaking, we can simply use the same buffer, right? Because I'm still appending stuff to it. So let's call this buffer, and let's also call this buffer, right? So how do we do leaf nodes? It should be very simple. If node.left is null and node.right is null, you simply say buffer add and you return from here. If node is null, we can do the check ourselves. If node.left is not equal to null, so we traverse a leaf node saying this, and then this, and in here we can call this right, we can call this right. That's pretty much it. Okay, so this is simply root, and in here you can give it a buffer, and that's pretty much it. Return buffer. Right. So now one of the things I want to check is root cannot be null. So if root.left is null and root.right is null, you're going to simply return buffer and buffer.add is. Otherwise we do that. So if we do this much, it should be the correct left and right traversal, a left and leaf traversal. 1 4 10 12. This is correct. This is also correct. Cool. Now the question is, only remaining part is left boundary, and we don't have to be very smart to do this. The reason behind that is we don't have to be very smart to do this. The reason behind that is we can always say that it's the number of times it actually goes through all the nodes. So the number of traversal node does is basically the number of boundary nodes that you have, right? So you can simply private look at that guy. Okay, so in here, if node is null, simply gonna return or node dot right is null. We're gonna do that. Now since we have to append it in the reverse order, one of the things we can do here is we can take a pointer and say that exactly what is the size. So whatever we have added to the end of it, we can reverse it, but we can do another thing. So in here, because we had to, like, as and when we process nodes, we had to add it to the buffer. So we did kind of a it's an in-order traversal, right? It's an in-order processing, I would say, because at that very moment I would process it, I'd say, if I'm not wrong. But here we can do a post order. So if node dot left, if node dot right not equal to null, because this is where we are doing this thing. So this, well, it's and. So left and buffer add node value. What you're talking about? What? Holy shit, there's a new method in here? Since 9, I didn't even know this. Okay. So we cannot say it's a branchless thing because it kind of already branches out here. So we cannot say it's a branchless thing. But yeah, it basically returns you back with the first non-null value. Okay, but yeah, I mean, this is readable. We could have done the same thing here. Does it say that I can do it? It doesn't say here though. I don't know why. Anyways, traverse right boundary, root right, and that should be it. Hopefully that should be it. And if I can solve this, I would say I'm a little bit teeny tiny solved it. Hold on. Holy shit. This is a submission. A year back, 1.5 years back. Look at it. 1.5 years back, I was not a good developer. 1 year back, I have improved a teeny tiny bit. One of the things to actually show that I am developing, I am growing, my problem solving skills or any kind of skills is going better, is to document, hence the entire part of streaming, to document the journey. But this right here is another evidence that I did actually get a little better. I might have cheated a little bit where I looked at the previous solution. And the previous solution, I feel I try to do the same thing, except I'm always doing a pre-processing before I do the traversals, right? It's basically an order thing, right? So I feel that's the problem right here. If I could remove this and do it in here and here, it's gonna pass. And we're gonna quickly, well, not that, we're gonna quickly test our hypothesis in here. What is auto? So moment of truth, it fucking failed. Okay. If direction is 0, I think one of the things we have to do here is, yeah, I tried to be a little bit more clever to, again, I did this external, okay, so it's stupid, never mind. But I feel like this is what I'm talking about. It didn't only be like, it's the correct implementation, I would say, because it's 0 milliseconds, and then here again it's O of n, and n being the number of boundary nodes that you have, right? not the entire number of nodes that you have, only the boundary nodes that you have. You're going to travel those only because you have your branching and stuff. And then on the memory side is Java, so 44 MB. I'm not going to comment on that. Who saw it in this way? Get left, get bottom, get right. Yeah, I mean, it's kind of the same thing, except that for get bottom, instead of that, I have this thing here. And I'm guessing you would pass no dot right here. No dot right, no dot right, no dot left, no dot left. I mean, I just put these two things together in a single, but it's the same thing. It's the same thing. So here somehow they had, it's one empty less, so it's not really a big deal. But yeah, in general, I think this is a good solution. This didn't work, and I'm not going to fix it right now. I'm just going to say, hallelujah, awesome. I did a little better than what I was doing 1.5 years back. So yeah, I think I'm happy now. I'm really happy now because I solved this. Cool. Okay, let's find something else. Let's do binary trees more. Binary tree, general, okay. Find leaves of a binary tree. Why is this a big problem? Okay, so given the root of a binary tree, collect a trees node as we're doing this. Collect all the leaf nodes, remove all the leaf nodes, repeat until the tree is empty. Given the root of a binary tree, collect the trees nodes as if we were doing this. Collect all the leaf nodes, remove all the leaf nodes, repeat until the tree is empty. So if you go back here, you would first collect 4, 5, 3, then you would collect 2, then collect 1. Okay. Apparently I solved it. Okay. I still want to see if I solved it with Python. I solved it with Python a year back. Okay, cool. Question is how? Very good question. That's a brilliant question, I would say. I'm just kidding. Just kidding, meine Freunde. So the level is not of importance here because of the fact that 4, 5, and 3 goes into a single list, because in the first level of removing all the leaf nodes, these were the leaf nodes. So one of the things you can always do is you can traverse, and while you traverse, if those are the leaf nodes, you simply can remove it. Sorry. But that particular thing would also mutate the input tree because these are all passed by references. These are objects on the heap. So that is not quite a good answer. Wait, 3, 4, 5. Okay, so the order doesn't matter. Since for each level it doesn't matter the order, we should. Okay, cool. Oh. Okay. So the entire problem statement is that you have 1, 2, 3, 4, 5. And in here, I am going to say that once you reach the leaf nodes, they are part of a group. Their parents are part of a single group. Their parents are part of a single group. That is how generally you can group together things. The entire question is, how do we figure out what the heck group they are part of? That's the, I think, the statement of the problem solved. Alright. So if I go down the tree and increment biases, so this is 0, then you have 1, this is just essentially the depth. This doesn't really help because this would be 1, but this would be grouped here. And usually for binary tree, you kind of try to do a recursive solutions. Right? You know what? We can assign the depths. Once we assign the depths, we can say that sorry. Why my music is stopped? You know what? We can go down the tree. We can go down the tree, and it can be level. Whatever level, doesn't really matter. Some level, right? Can be some level. And in here, once you reach that particular level, we can call that as 0. We can call that as 0. So, and we return back like level. So that particular level would be level plus 1. So since this is 0, we first check that there's a buffer we are moving around the particular function. We are passing it down to the particular function. Does it have enough length? If it doesn't have enough length, we're going to add it to it. That should be the answer. That should be the solution. I hope I was able to explain it. If not, do ask me questions and I'll try to explain it again. 366. The same thing. Okay. I don't like to call it if node dot left is null and node dot right is null turns 0. If accumulator is empty, accumulator dot add new rows, accumulator dot get first dot add second, and then it returns int current level is there's one problem here. I did not anticipate that problem. I'll tell you exactly what the problem is. So this is this. After 5, let's have 2 nulls. And then 1. No, we need more nulls. What about now? Because this here is gonna return 0. This will be 1. But from this level, this is 1, 2. Question, where do you get that, right? So let's look at the answer of what exactly gonna happen. It's not in 1, it's in 2. So you always take the max. Yeah, always take the max from where you're coming. That's all. Left level should be this. And so if -1 comes, it becomes 0. Hmm. Hmm. So अगर हमें the level is 2, we need a size of 3. And here we have to say with the root and accumulator turn accumulator. I'm not wrong. That should be it. Yes. Thank you. Awesome. I'm getting a little bit more confident on this. Cool. That is pretty cool. Let's look at how I solved it before. Here, DFS. If node.left is none, I did the same thing. 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 Okay. Yeah, so only good thing here is that you have closures, so I'm taking the bind of nodes from outside in here. I didn't have to do non-local, but for well, it doesn't have primitives, everything's an object, but for those kind of types you have to do that, so I just do it for everything. But yeah, I mean, I didn't even do this kind of thing in here, but you have to. Technically it's not required because it cannot hit this. It cannot hit this because if it's a terminal node, it will be hitting this first. So we can even do that. You know what? Just to test the hypothesis, yes, with valid test cases, it shouldn't hit that. So I'm just gonna put this here as a stopgap. That's all. Cool. I think we did 3 problems today. Binary tree, vertical order. Binary tree, vertical order. Okay. Given the root of a binary tree, return the vertical order of its node values from top to bottom, column by column. If 2 nodes are in the same row level, the order should be from left to right. Okay. So how's it? You have 9 on this side. Then you have 3 and 15 here because okay. And then there's 20. So I remember I solved this now, like I remember the solution, how I have done it. And basically what I kind of do is do biasing. So if you go left, it's -1. If you go right, it's +1. And that is how we do that. But the problem here is on the left hand side, you have to kind of like take a mid pointer and say, oh, like how many elements are there on the other side of the mid pointer. So like the starting mid pointer in the sense is like the 0th position is not really 9. The 0th position is this, which is 315. And you have to kind of shift it accordingly. So it kind of becomes complex. And what I'm thinking here is a very simple thing that we can take. I mean, at the end of the day, it's gonna be a little inefficient because of the fact that you will be having underlying buffers resizing and all that. Probably that is more micro optimizations than real optimization. Most likely it is not a real optimization, and mostly it's a micro optimization, I feel. Apparently there's news coming out for 30,000 jobs being 30,000 people losing their jobs. There's apparently 30,000 jobs being 30,000 people losing their jobs today. It happened today. Amazon stock price is almost 228 USD. What happened in the last 6 months, I wonder? Okay, it still went up quite a bit. 187. A year to date, 5 years. From 165 you went to 237. It's not even double, it's 1.5 times almost, I think. It's probably 1.5 times, 160 plus 80 and a little bit above, over and above, which comes out to 280. But I mean, just a second. I mean, this guy says 14,000. This guy says 30,000. I wonder if it's for Amazon chassis or something. Andy chassis, Amazon as startup. An operating, okay. Oh my god. CEO Andy Jassy shares 7 ways to strive, blah blah blah. Third, we want owners. One of the strengths of Amazon over the first 30 years is that we have really hired smart, motivated, inventive, ambitious people who had been great owners, and that means that our teammates are constantly asking themselves, what would I do if this was my own money? What would I do if I started this company and I was a majority owner? Hey, I know I've only been asked to own a part of this project, but I'm not sure if the other parts are being driven well. Should I stick my nose into this and make sure that trust or just trust somebody's got it? Owners feel accountable. They care deep about the quality and effectiveness of what they own and view the company's mission as their mission. We want missionaries and not mercenaries. That's part of what our effort to increase the ratio of individual contributors versus managers is about. Yeah, so they were trying to get rid of, like he mentioned somewhere this year, doesn't say the date. Doesn't say the date on the article. 14th April. I don't know if that's a published date or not. Like whatever date that is and how they. That is one thing I never really looked at. So this is EM dash, ain't it? So I think you can do exit. Yeah. So Python here and ordinal of this thing instead of this thing. Yeah, I feel that's the EM dash. But anyways, nonetheless, like I've never seen it used in real life except ChatGPT apping. But yeah, going back to the point. Okay, first whatever we are blah 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 and all. So he mentioned something about middle management. Or did he not? Maybe I heard it in some like some YouTube video or something like that. Fifth, you have to be scrappy. As business succeeds and gets larger, they sometimes forget how things got started. We built Amazon's S3 with 13 people. EC2 with 11 people. Managers can confuse themselves that the way to grow and get ahead is to accumulate large teams. Historically, we have periods where we have allowed this kind of thinking to hold sway, but it's not for fundamentally thinking about building teams. That's the problem. That is one of the problems every company has. Every company and managers, well, not managers, I would say decision-making things, is that there are two things to it, I feel. Every time they need to make a decision, they feel that throwing money at the problem would solve it. That's one problem. The second problem is, I don't think so. That's the problem. No, but I think the first problem is throwing money at a problem would solve it somehow. Second problem is, when you are at a crossroad of taking a decision, it's general human nature, I think, when you're at a crossroad of taking a decision of whether you took a correct decision or not, you're always just going to pass the baton down to someone below you and say, hey, that person didn't take the decision correct. Well, to hire managers with, to grow as an MNC, Amazon is an MNC right now. Amazon total strength. Employee strength, how much is it? 1.6 million employees. Okay, let's look at this growth. Year by year. Can we get this? 24,300. I don't know when was Amazon born, but whatever time Amazon was born, like, yeah, whatever. 24,000. This thing. You can see a clear graph of how they boomed and how the hiring went up. You cannot have 1.56 million employees working for you and call yourself a startup. You can say certain teams have certain mentalities of startup, because there cannot be a single or 5 people manager for 1.5 million team, right? You cannot even have 100 people managing 1.5 million people. You would have small teams. Each team, okay, let's do that. Divided by 20. Let's say there are 20 people. You need 77,800 managers at certain levels of hierarchy, right? So again, within this, you might have 100 managers who report to another manager. That level of hierarchy would report to another. So it's a tree. You build a tree. You build a tree because you wanted to grow. You build a tree because you wanted to make more money. You build a tree because you had a vision of going global, and you did. And you went beyond just Amazon went beyond just an e-commerce website. You have AWS and things like that, which is more tech oriented, and everybody is using them to actually grow their business. So you made a choice to hire so many people. But when it came to accountability, so again, if you have this graph, usually these are the graphs that you have, right? And it's not like a binary tree. You would have an NRA tree, right? So when it came to accountability, at certain points, these people higher up, like this depth goes way down, right? These people took a decision, and every vertical took their own decisions, right? Someday, somewhere in this particular level, or maybe a little bit more, maybe a little bit less, I don't know. Right now we're talking about Andy, so this is on this level. So at a certain point, when the decision came that, hey, we kind of lost our vibe down the path because you did this, because you went for 24,300 to 1.5 million, which, like I mentioned, even if there are 20 people in a single team, you have 77,000 teams. So you have 77,800 managers in each team. Let's say some teams might have 2 managers, whatever it is. That's how every team and every company works. And you made a lot of money and everything. And when it came down to say that, hey, we are strategically changing how we operate. We build a certain product with 12 people. We build a certain product with 11 people. When he says these things, right? Yeah, we built Amazon with 13 people. We built EC2 with 11 people and all of that. They would just say, let's do prop drilling. That's what you call in React, right? Let's pass the data down to the child component and say, hey, you're the problem, buddy. No, you hired them in the very first place. You had a decision to make and you decided to go global. You decided to hire more people. I think WhatsApp went global with 32 engineers, or Discord is still operating with 32 engineers. At least that's what I know, but don't quote me on that. Maybe they're hiring good now. But the point here is that, but the big point here is that there cannot be a single person. If you're a startup with 100 people, 200 people, you can have a bunch of managers, 10 managers, maybe with every CEO, CTO, and things like that, who making decisions. And within those 100 people, within those 500 people, everybody can talk to the CTO that, hey, sorry, why did you make this technical decision? Even and probably an intern can go up. I have never worked in a startup, but I'm assuming that's what the culture is, where you can just walk up to CTO and say, hey, that I know you took this decision, but why exactly? Maybe you're asking for knowledge. Maybe you might have a better solution, or say that, hey, so that kind of thing is possible if you have 500 employees. If you have 1,000 employees, I don't know, maybe if you have even 5,000 employees, that might be possible. But in this particular case, you taking a decision 5 years, 10 years back, 6 years back, 3 years back, and then when it's not working out, specifically you want to save money and pump it into AI, into the race. You're taking away jobs and you're saying that, hey, it's a strategic decision for us. Why the fuck did you take a wrong decision to start begin with? I mean, if you cannot see the future, maybe you shouldn't be the CEO, right? If you cannot predict the future, if you cannot predict how, if you cannot even think about how in the future my company culture should be like, someday you say, hey, we're going to grow so high, we're going to be billionaires, and we're going to have, a huge company, we're going to need to go global for all of this. Someday you're like, hey, we went too big, man. It's not working out. We need to come back to the roots. Did you come back? Are you coming back to the roots? Maybe we're working out of garage. Are you still working out of a garage? No. So that is my take on things like that. We talk about AI. One of the things I would like to say is, it's great. I use AI a lot. I don't use quite often as people ask me to do, but I don't. And I feel like people have also asked me, hey, have you started working with AI? What I mean is, have you started using AI tools? I am not in favor of using an AI tool. I'm in favor of building some AI tools, or, learning the maths behind it. So I want to spend time with that and not just play around with tools. That should be part of my workflow. It shouldn't be part of where I learn. Like, I don't have to spend dedicated time to know how to talk to an AI. After 5 days of making mistakes, I think I can learn how to talk to an AI. I did learn programming in that way. I know exactly, like, for 5 days it didn't work, and the 6 days started working. I just realized, oh, you don't do these things. Maybe you can do a couple of other things which works, but I have to absolutely know what doesn't work. I think that's a huge part of software engineering, right? But for AI, if we talk about it, people with a lot of money and power, and what is it called? Not preference, I'm not getting the word. Influence, sorry, not preference, influence, will try to pump in money into AI because they want to make more. Great, awesome. But here are two things that I absolutely feel like. One, probability, AI has maths behind it. At the very bare bone minimum, it's maths with a probability, right? Let's Google. Let's ask ChatGPT. If I have to define a LLM to a 5-year-old, how would you define it? What does it do? Let's say, if I have to define an LLM to a 5-year-old, how would you define it? So first, large language model is a very big talking brain made of words. It has read lots and lots of books, stories, and websites. So when you ask something, let's read this very, very carefully. So when you ask it something, it guesses what word should come next, kind of finishing a sentence until it makes a full answer. Okay, so the 5-year-old answers back, what if your guess is wrong? Many times you can get the answer wrong. What are the implications I mean, I use the word implication, probably a 5-year-old will not use that word, but anyways, that's a really smart question. You're right, sometimes I do guess wrong because I don't know things. I just look at all the words I've seen before and try to, because I don't know things like humans. I just look at the words I've seen before and try to guess what fits next. Humans also do the same thing. Yeah, it's like you were finishing someone's sentence but you really didn't know what they meant. You might say something that sounds right but isn't. When I get it wrong, people might believe something that isn't true. So it's very important that humans like you, your parents or your teachers, check my answer, just like you check your homework before showing it to the class. Now, same question to a maths PhD. Explain what LLM is. Let's look at what it answers. Here's how it runs for blah blah. Cool, again. They use the word probabilistic, but not necessarily blah, probabilistic. An LLM is a high-dimensional probabilistic model over sequences of discrete token. So the point here is that, my point here is that, now again, we can have counter opinions on it. Even I can counter myself what I'm going to say, but what I feel right now is that what I'm going to say might make sense. Okay, so if you ask me to write a piece of code which accepts a function of it's a function which accepts 2 parameters and it returns back the sum of it. Me as a software engineer, I exactly know how to sum up 2 numbers. Me as a Java developer, I know exactly how the syntax works. I'm not guessing the syntax, I know the syntax. I'm not guessing how to sum things, I know how to sum things, right? And this is when I can write a function which compiles and it works of what you asked me. There is a probability, in my opinion, of 100% that if you give the requirement correct, the person is going to code it correctly. There are bugs, I understand, again, edge cases, but it's a very simple case right now. Let's take a very simple case for the sake of the conversation, right? There is a very 100% probability that I got it. There's a 100% probability that I get it right because I'm a Java dev. I know maths, I know basic maths, I know how to sum up 2 numbers, I know how to write a function, and that's all. For the LLM, to a 5-year-old, this is not my words. I was using the words, but I just asked, maybe ChatGPT is listening to me, I don't know. It guesses what words should come next, which means it can never be 100%, because if it's 100%, you're not guessing because you absolutely know that, right? That's one thing. Where is it? Excellent shift, blah 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 blah, yappy. Where did you write it? So it's a high dimensional probabilistic model. It is generating something which has a probability of being right. The more you train the model, the probability becomes higher. But does it ever reach 100%? And do you really want to reach 100%? There is a really good stream about it. And I feel that you should see this because it's developing a neural network from scratch. And in C. This guy, Alexei Kutepov, Soding Daily or Soding, his hacker handle is Soding, I think Hacker News or something. He basically created a... He's an amazing software engineer, and he's an amazing engineer. He understands maths really fucking well. He created a machine learning neural network from scratch. C. ML playlist from Sorting Daily, written in C. He wrote it in fucking C. Okay, and it's not just a loly-poly thing. He starts with something loly-poly. Neural network can see that, recognizes shapes, and I think he can also generate videos. My AI can generate videos now. Okay, so he goes behind the entire maths and everything. I think you should follow this channel for actual software development. He calls it recreational, but man, I have learned more following this channel in the last 2 years than I have done in my entire career. Straight up. Okay, someone might get offended, but that's the truth. Anyways, coming to the point. So you're relying on a probability of less than 100% for something, when you can have that thing for 100% thing. So it feels, I'm not saying we are going backward, I just feel that we are taking a lot of bet on something which is again based on probability. That's one thing. I'll give an example. Hash tables and Bloom filters are the same thing. Given a key, we need to answer the question that if that key, or given a value, if that value exists in a set of values. Well, the only difference is hash sets or hash maps can give you a very correct 100% probable answer saying if it's there or not. If you guys don't know what Bloom filters are, just Google it up. Bloom filters are a probabilistic data structure which gives you, with proper tuning, you can tune the probability of correctness. What does it mean? So it means that there's a probability of this value being present and the value not being present. So if you give a value, it would say that this much is the probability of this value being present in the table. But if it is not present, it immediately says that no, wait. Did I say that wrong? I think I said it opposite. That's correct. I said it right. If it's there or not, it gives a probable. But if it's not there, it gives 100%. Or possibly in the set, definitely not in the set. Okay, yeah, so I was correct. It's a false, it never gives a false positive. So it never tells you that if value is not present, it never tells you that value is present. It would always tell you the value is not present. So this is more like, okay, you can do a Bloom filter, and okay, I stopped it. Space efficient. So this is the entire thing. Bloom filter is a hash set, but it's a space efficient thing. So since you're compromising on space, you have to, trade off something else, the classic software engineering thing. So you trade it off with a probability. And how much probability you can, tackle around, you have different maths for it. Bloom filter probability calculator. There is something in here. Hurst. This is the one. Yeah. So you can say that number of items in the filter. So you're gonna take, let's say, 1 million, 1, 2, 3, 1, 2, 3, 1 million items, and this is the probability of false positive. And this is the number of bits in the filter. So let's say you have 1 GB, right? The number of hash functions, you can have 10. I don't know. Clear a field for me to try. Yeah. So it's gonna give you the number of functions that you need, number of hash functions that you need, right? Is it not working? No, it is working. Yeah. Okay. So K is 2. Okay. So 1 GB. What if you needed something less? So let's say 100 MB. So your number of hash functions goes up, and the more you want probability better, the number of hash function goes up. So your compute power, needs to be better. And these are not like non-cryptic hashes, and like Murmur hash, and there are a couple of others, FNS or something. I don't remember the name. Should actually do a stream on that and learn for myself. But anyways, so the point is that you are always trading off probability with something else. So do we really want to give away a lot of things to LLM? Things where probability is the answer. It's not 100% absolute certainty. So you're trading off certainty with probability to save money. I don't know, I quite understand the mental model behind it. I don't quite understand that, I'll be honest. Okay. if I'm building a machine at some point, your factory lines and things like that might be, using AI, which might cause issues, physical harm. But we are leaving that to a probability. I mean, some AI guy can come and, talk about, hey, you don't understand AI, so don't stop. I mean, yeah, that's correct. I don't understand AI. But what I understand is that, are we really moving forward? That's my entire question here. We traded off certainty with probability. We are trading off lives with one person making more money. So if the graph was something like this, where the number of people having a lot of money is definitely a lot less than this entire population here who doesn't have a lot of money, and these people kind of like, just think of it in an exponential graph, and then it somehow kind of goes to like, like meet where people are not able to meet their ends. What we're essentially trying to do is again what I feel. What we're essentially trying to do here is, okay, how do I select this motherfucker? What we're essentially trying to do here is that, can I do another breakpoint? I cannot. So it just feels like that. I mean, I don't know if I'm able to explain it. I'm just feeling like, okay, and this guy should, extend in here. So number of people behind that will increase, while the same people who had a lot of money, amount of money goes up. How it's gonna help? You're gonna go to Mars for what? I'm gonna go to Mars. I may be a child molester, but I'll go to Mars. Anyways, a complete digression from actual topic for almost like, I don't know, half an hour or so. Yeah. Okay. A lot of opinions, and the opinions are my own. Just some sayings, okay? Wrong, correct, narcissist, it doesn't fucking matter. The opinions are my own. Let's quickly go. If somebody's watching and you really like what I said, never mind. I'm gonna do it. I was thinking of clipping and sharing it. That's what I'm gonna do. Okay, so coming to this problem, how I'm gonna solve this problem here is that I'm gonna say that you have this thing, 3, 9, 20 grab. So I'm gonna have a cursor to show what the midpoint is. So how is it? 3, 9, 20, 15, 7. 3, 9, 20, 15, 7. So in here, I can always say this is 0. This is -1. This is +1. This again is -1, so it's 0, +2. Okay. So let's take this thing here. So 0. If it's 0, then it's midpoint. So like cursor thing, right? Cursor is 0. So we add it to that. Then it comes to -1. So -1 essentially is a point on the other side. So how do we know? So length is 1. Length is 1. And what is the length of this part? Excluding this. The length of this part is cursor -1 -0 +1 equal to cursor. At this point, the length is 1. But if it was only this, so cursor -1 -0 +1 equal to cursor, which is equal to 0. So length is 0. So what I have to do is I have to add a bunch to the front of it. I have to add a bunch to the front of it, and I have to move my cursor +1. So that would mean that now this becomes the midpoint of it. That's usually what I think I'm going to do. Yeah, that is the way I'm going to solve this problem. Let's get some music time. I really want to play some other music, but I don't know like how it's going to affect the license. No. Oh, right. Lo-fi sounds. Uncopyrighted lo-fi sounds. Okay. Let's see. Let's see. 3, 1, 4. Okay. So this can be private static. Okay. Private void and here is 0, or let's call it origin. Is that a good one? I think that's good. Okay, I think that's a good one. So if node is null, we you can simply say int offset. I'm not sure what's the word to use. Yeah, offset. So we don't do anything. Here we also return. Do we? We don't have to do anything actually. So now vertical order node left offset -1. What the fuck are you doing, man? Origin.
As you know, that was a done deal long ago.
That's how you go left and right. Go left and right. So now add. You can do it here. Okay. If offset is 0. So the question is, can it be null? It can be null. So we have to remember to handle set. If is empty. Get origin dot add this thing. else if offset is less than 0, not 2, what is that we are going to do? So number of elements, let's call it n. Where is it? Where is it? Origin -1 -0 +1. Okay. Then is that right? It basically comes down to origin only. Take it, like being explicit. So if offset is greater than or equal to n, what we have to do in here no, you know what, we can do a different thing in here, because if you look at -1, it is origin -1. If origin plus offset, because offset is negative, if it's less than 0, that's what you do. If root is null, turn your list top left. We don't have to do that. Vertical root offset is right now 0. So we add it and pass it. Wait, yeah, offset is 0. Origin is also 0. Then you simply return this, and that should be it. How is this lo-fi? How is this lo-fi? How is this lo-fi? Just good. LCS songs. Let's just listen to this. My math is not correct, so I just have to see this. So if offset is like negative, what do we do in here? We simply say the index is basically also, if the offset was -1, It's origin plus minus 1. That's wrong. That's right. We have positive height. Positive height. Okay. Origin is 0. See, what is happening here is that when you go for the first round, it says it's, let's say, minus 1. So origin is already 0, so there is no gap in there. So then you say minus 1. So minus 1 is 0 plus minus 1 is minus 1, so it's less. So how many do we need? We need just 1, right? So you add it and you move origin to this thing, right? Move origin to this thing, and it was minus 1. So you can always do plus 1 here. That didn't work. That's fine for now. What is the issue? 9. The fuck? Why did 15 get minus 1? I think that has also to be plus 1. Minus 1? Oh. Trying to do something chaotic, doing some. Okay, let's do the maths by hand because I'm definitely fucking up something. So let's say this here is your missing and this is origin, and you get minus 2. So origin plus offset equal to 0. So you can easily get this and add it to it. Done. Khatam. Kissa khatam. What if you get offset equals 2? So you say origin plus offset, which is, or this is 2, plus 4. 1, 2, 3, 0, 1, 2, 3, 4. That's correct. Problem ta kothay? Phil, this has to be. Because I'm changing the origin here. I think that's one of the things. Okay. I still am messing on this one. Is it the same issue with others? Yeah, apparently. Apparently my math is wrong. Okay, it's already 11 o'clock. I think this is the last problem that I'll solve. I already want to log off, but I want to solve this and then go. It's a very stupid problem statement that I have. Done. Okay, I'm gonna do this. I'm not gonna be super smart in here. Int length is nothing but origin minus 1 minus offset plus 1. This is the length. If int index is you do have the origin at 2, and at that point you're saying the length is pop, 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 pop. Okay, I'm gonna take this tomorrow. For today, this is gonna be the end of the stream. It's already 11 o'clock, so I'm gonna end it here. So I'm gonna end the stream here. This basically is just a bit of maths issues that I'm facing, and my mind is not working right now. So I'll see if I can solve it in the night. If I actually have, plans to solve it in the night, I'll solve it in the night. Else I'll be doing it tomorrow again. Sorry, maybe tomorrow I don't stream, because tomorrow I have some work in the evening. Maybe tomorrow I don't stream. But let's see. Yeah. So thank you so much for joining. Thank you so much for joining and supporting the stream. Thank you so much. I hope you had some things to learn. And what we're gonna do right now is we're gonna just quickly, oh, your parents don't have a, did I? No, I did not. Okay, sorry. You can also have attributes. Yeah, so commit is done. This is basically it from my end. Thank you so much for joining. In case tomorrow I come live, I'm gonna keep continuing to work on this. Yeah, that's a plan. And let's see tomorrow how we fare. Tomorrow there are a couple of things that I have got, and maybe I don't come online. But yeah, thank you so much for joining. Have a good night. Thank you. Bye bye. Bye bye.